When we're trying to describe a relation, what we're going to find is that most relationships end up being relatively similar. So I wrote some common relations over here that we can use to kind of guess and then tweak what, relationship our x's and y's have here. As a reminder, the first term is the input or the x, and the second term is the output or the y. So we have our x's and y's here, and we have to figure out how they're related. Now, one of the things we could do is to start a simple table. So we have an x, we do something to it, and it gives us a y. So let's go ahead and start with the first term here, or the first ordered pair, and we have a 0. Then something happens to that 0, and it spits out another 0. Well, that actually gives me some good info. That tells me that I'm clearly not adding anything to it, so I don't need to worry about that. And actually, to be honest, that's all that it really tells me, is that I'm not adding anything to it, because 0 plus anything wouldn't be 0 anymore. Okay? Now, that's not a hard and fast rule, but that's something that I'm noticing, and it could be true. So let's look at another x value here. Let's say 1, and then we're going to put it in. Something's going to happen to it, and in this case, it spits out a y, or an output of 5. So what could I do to a 1 to give me a 5? Well, there's a couple things that I could do, but one of the big ones is I could just multiply it times 5, right? So let's see if that works for our next value here. So I have an x value of 3, and then I'm going to output or do something to it, and it's going to output a 45. Well, that's already looking like that's probably not going to work. Yeah, 3 times 5, it's definitely not 45. So what am I missing here? Well, I'll tell you, there's actually a way I could have already known that that wasn't going to work, and that's by looking at how much these are increasing here. So let's do that real quick. We know that this one goes up by 5, and then the next one goes up by 25. And then the next one after that goes up by 35. So it's going up by a non-constant amount. That actually tells me that it's not going to be a linear function, so I can actually get rid of this one here. Well, if that's the case, what else could it be? Well, I do have this squaring function here, and I know that when I square numbers, like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Well, these are going up by a non-constant amount as well. And in fact, that 3, 5, 7, well, I've got 5, 25, 35. That's actually kind of a similar way of increasing. So maybe that has something to do with it. So what if I squared my input? Well, 5 times 1 squared is still 5, so that worked. And what if now I go 5 times 3 squared? Well, that's 5 times 9. Oh, yep, that equals 45. Now, I'm not confident it works yet, so I'm going to try it with one more value. So let's try plugging in 4. And 5 times 16 does equal 80. So this is looking pretty good. So let's go ahead and formalize our rule here. So we know we're going to take x and we're going to square it. And then after we square it, we just multiply it times 5. So there is the relationship we're looking for. Y equals 5 times x squared. So by looking at a few examples and by comparing them to a list of pretty common relationships, we can come up with a way of formalizing this relationship as a function.